Hi there, folks. This is the Unit 6 review, and as always, I am the amazing Mr. Jansen, so away we go. If we take a look at this first one, we want to solve by graphing. Remember, anytime we're looking at a system of equations, especially when we look at it from the perspective of a graph, whether it's a system of equations or system of inequalities, we're kind of looking for the overlap between the two things. And so for the case of a system of equations, that overlap is a single point. So we're looking for that single point of intersection, that one thing that they have in common. So all we're going to do is graph each of these. So that first one has a y-intercept of -4 and a slope of 2. So up 2 over 1, up 2 over 1. So we graph that line. And the next one has a y-intercept of 1 and a slope of -3, down 3 over 1, down 3 over 1. We draw that line. And we just look and see, oh, they intersect right here. That's at the ordered pair 1, -2. So we write our answer as the ordered pair 1, -2. And really what that's telling us, it's solving for x and y at the same time, saying x equals 1 while y equals a 2. Okay? These guys solve by substitution. When we're solving by substitution, we need to get one of the variables by itself. And when we look at this first equation right here, the first equation already has y by itself. So in other words, y equals the expression 3 minus 2x, which means when I go to my second equation, any place I see a y, I can replace it with the expression 3 minus a 2x. So again, because y equals this thing right here, I can substitute that in for y in the second equation. And now I solve. And the nice thing what's just happened is basically I'm left with an equation that only has x values in it. So here I distribute that 2. I combine some like terms. And I solve. I'm going to subtract that 6 from each side. And then divide by the -1. So I find out that x equals a +5. Well, I'm not done yet. I have to plug it back in to get the y value. Well, right here, I have an equation. Y equals 3 minus 2x, and I just replace the x with the value that it equals the 5. So I've solved it. X equals 5, y equals -7. I'm going to write it as an ordered pair because that's just a nice, succinct way of writing my answer. X equals this, y equals this, and I wrote my ordered pair backwards. Let me try again. So there we go. Okay. Next one, same kind of thing. This time, I don't have one of these by itself already. So if I want to solve by substitution, I need to get one of the variables by itself. Look for the one that's easy to get by itself. When I look at this, it looks like y in the first equation is almost by itself already. So I'm going to solve that first equation for y. So let me take this off to the side. And if I want to get y by itself, I'm just going to subtract that 3x from each side. And this should feel familiar because it's like getting slope-intercept form, -3x plus 4. And now y equals the expression -3x plus 4. So I take my second equation, and any place I see a y, I replace it with a -3x plus 4. And now I solve the equation that's left. I use my distributive property. It gives me a plus 9x minus 12. I combine like terms. Now I solve. I'm going to add that 12 to each side. And divide by the 13. And so I find my x value is going to be a 1. But I'm not done yet. I still have to plug it back in to get the y value. So I come back over here. Y equals -3x, which is a 1, plus 4. And I just simplify. So y also equals 1, so it's the ordered pair 1, 1. Okay. The next couple asked me to solve by elimination. Remember, elimination, we want to get these kind of in standard form. And really what we need is we need everything to line up. I need the x's lined up, the y's lined up, the equals lined up, the constant lined up. And then I have to get additive inverse. I have to get opposites in front of one of my variables so that when I add the two equations together, those variables cancel out. So when I look at this one, everything's already lined up. The x's, the y's, the equals, the constant. So everything's lined up. I'm ready to add this thing together already. Okay? And because I have a positive 1y and a negative 1y, when I add these up, it's already set up perfectly that I'll get a 5x. The y's cancel out completely. Over here, I add up and I get a 25. And that's the idea. We want them to cancel. It just so happens that in this one, they were already set up to cancel. All right. Some of these other ones, we might have to do a little bit of work to get them to cancel. So I get an x value of 5. I'm not done yet. I got to plug it back in. So maybe I'll plug it into this first one. And I got to subtract that 10 from each side. So I get the ordered pair 5, negative 5. The next one's similar, except not as much work is done for me. When I look at this thing, first of all, not everything's lined up. So it's not lined up, so I got to rearrange this thing. So I'm going to take this first equation, and I'm going to rearrange it. I'm going to get x and y on the same side so that it's kind of like in standard form. And I'm going to do that. Sorry, that was a minus. By adding that 3y to each side. So now that second equation becomes this. It becomes 4x plus 3y equals a 7. Now everything's lined up. Now I need to get additive and inverses in front of one of these. So unlike the last one, I can't just add these together. If I add them up, the x's aren't going to cancel. And if I add them up, the y's are not going to cancel. So I need to get additive inverse. So I look at like the 7 and the 4, I look at the 2 and the 3 and say, how can I make those the same? It's a little easier because the numbers are smaller for the 2 and the 3. So I'm going to multiply this first equation by something like 3. And I got to multiply the second equation. See, because if I multiply the first equation by 3, it'll give me a 6y. So now in the second equation, I need a negative 6y, so I'm going to multiply by a negative 2. And so I'm creating a situation where I have additive inverse. So now the first equation becomes a 21x plus 6y equals 27. The second equation becomes a negative 8x minus 6y equals a negative 14. And now if I add these up, the y values will go away. So over here, let's see, that's going to give me a 13x. The y's cancel. Over here, these add up to a 13. And now I can finish solving this thing. I divide each side by 13. And I find out that x equals a 1. I'm not done yet. I still have to plug this back in and solve for y. I can pick any one of these equations. Maybe I'll use this one, the 7x plus 2y equals 9. Oh, but I forgot I'm going to replace the x with a 1. And now I have to solve this thing for y. Subtract that 7. And divide by the 2. And by a happy coincidence, I got the answer 1, 1 again. Who'd have thunk? Okay. But again, substitution, get one variable by itself. Plug that expression back in for that variable in the second equation. Elimination, we get additive inverses, and then add the two equations together. Okay. So these say solve by the method of your choice. And really, we choose elimination when one variable is by itself already or easy to get by itself. We choose elimination when we look at the format and we see kind of standard form for each one. We see everything lined up. Okay. And so for this one, very first one, this already says y equals this expression right here. So if y equals that expression, I can plug that in for y in the second equation. So I replace y with a negative 3x plus 1. So that equation becomes this. And I can solve. And this is just substitution. So now I'm going to add the 3x to each side. Got to get my variables together. Add that 7. And divide by the 4. So I find out that x equals a 2. I still have to plug it back in to get y. I'll plug it back into this one. Y equals 2 minus 7. So y equals a negative 5. Okay? So it's the ordered pair 2, negative 5. The next one, the first thing I notice right away is that everything's lined up. The x's are lined up, the y's are lined up, the equals constant. So this one screams elimination because everything's lined up. So I have to get additive inverses. When I look at like maybe the y's, I can turn each of those into a 15. So I'm going to multiply this first equation by 5, which is going to give me a 15y, which means I need to get a negative 15 for the second equation, so I'm going to multiply by a negative 3. So let's see, that gives me a 30x plus 15y equals 30. Here that gives me a negative 24x minus 15y equals a negative 36. And now I add them up. So this gives me a 6x. The y's cancel. Over here I get a negative 6. And now I divide each side to solve for x. So x equals a negative 1. I still need to plug it back into one of these. So like here, 6 times negative 1 plus 3y equals 6. And now I'm just going to solve this for y. I'm going to add that 6 to each side. And then divide. So you get y equals 4, so it's the order pair negative 1, 4. If I look at the next one, once again, everything's lined up, which to me says that I should do something like elimination. All right, x's are lined up, y's are lined up, equals constant. When we have that alignment, elimination is usually the best way to go. And so when we look at this one, looks like the x's would be easy to eliminate because this has a 2x and this already has a negative x. I just have to multiply this second equation by 2. See, because the top equation has a positive 2, I need the second equation to have a negative 2. So the first equation stays the same. The second equation becomes a negative 2x minus 4y equals a negative 6. And now I can add them up. And I kind of get into a strange situation here because when I add up the x's, they're gone. When I add up the y's, they're also gone. So I get a 0 over here. And that's okay. I just need to check to see what I get on the other side. 6 plus a negative 6 is also 0. So because I got a true statement here, this means infinite solutions. It essentially means that I have the same line twice, which means all of their ordered pairs are going to be common points. So all of their ordered pairs are solutions. So there's an infinite number of solutions. Okay. If I look at this one, when I look at this one, things are not lined up. So I can either rearrange it to line them up, or because I look at that first equation, y is almost by itself, I can easily get y by itself. If I take that off to the side, y plus 2x equals 6. And so I can either take this top equation and rearrange it to line things up, or I can just solve for y. So I subtract the 2x from each side. And now I have an expression for y, so I go ahead and plug that in. So here I have 3x minus 2. Instead of y, I plug in the negative 2x plus 6. And now I distribute. I combine like terms. And I solve for x. I'm going to add that 12 to each side. And divide. And now I'm not done. I got to plug it back in and get the y value. So over here, y equals negative 2 times the 4 plus 6. And so I got my answer. It's 4, negative 2. And this one would have been pretty much just as easy to do by elimination. Okay, elimination, you would have switched the places of the x and the y in the first equation, and then maybe solved that top equation by 2 to get added inverses in front of the y and then canceled out. But really, if I'm going to start rearranging an equation, I might as well solve for one of the variables if it's easy and go the route of substitution. Okay. This one student bought 3 pens and 4 pencils for $5. Another student bought 7 pens and 12 pencils for $13. How much did each pencil and pen cost? And so this one, they're describing each equation. Each sentence kind of gives me an equation of this thing, and it's being described in standard form. So what I'm going to do is I'm going to say x is the pens and y is the pencils. So that first statement is 3 x's, so 3 pens, plus 4 y's, 4 pencils, equals $5. The second statement is 7x plus 12y equals $13. Okay, 7 pence plus 12 pencils. All right, and so when I look at this, substitution versus elimination, it looks like everything's lined up, everything's in standard form, so elimination is probably the way I'm going to go. And I just have to look at this and say, I'm going to multiply this first guy by a -3. And I do that because I already have a 12y in the second equation. To turn that 4y into a -12y, I have to multiply by -3. And so when I do that, this equation becomes a 9x minus 12y equals a -15. And now I can add these two equations together. So that gives me a 16x. Over here, I end up with, looks like a, oh, sorry, I made a mistake here. I'm missing my negative sign. Sorry, this was a -9. I missed that sign, so this is actually a -2x. Over here, I get a -2, and now I can divide each side. And I knew there was a mistake there because I was about to get a negative answer for my values. Okay, so I get x equals a 1, so it's $1 for the pens. I got to plug that back in to figure out how much each pencil costs. So over here, I'm just going to solve this. So over here, I get a 2. I divide each side. And keep in mind, we are talking about money, so don't get scared of the fact that we're about to get a decimal here. 2 divided by 4 is 0.5. So in other words, it's saying the pens cost $1 each, and the pencils cost 50 cents each. Okay. If I look at the next one, it says tickets for a school play cost $4 for adults and $2 for students. At the end of the play, the school found they had sold 105 tickets and collected $360. How many tickets of each were sold? And so again, I'm just going to use some generic variables here and say adults is X and students is Y. They give me two pieces of information: the number of tickets sold. And so if X is the number of adult tickets and Y is the number of student tickets, X plus Y should equal the total number of tickets, which is 105. But then they also tell me about the cost of these tickets. It was $4 per adult plus $2 per student should equal the total cost, which is $360. And so now I have an equation. Each of them is lined up, so I could do elimination here would probably be the best route to go. Although substitution would also be easy. I could solve that first equation for X or Y. But I'm going to multiply this first equation by -2. You could also multiply by -4 to eliminate the x's, but I'm always going to choose the value that's a little bit smaller. Okay, so that's a -2x minus 2y equals a -210. And then I just add these up. So I end up with a 2x, the y's cancel out. Over here I get 150, and now I divide each side. So I find out that x equals 75, so there were 75 adult tickets sold. I need to plug this back into one of these equations. The top one's probably the easiest to figure out how many student tickets are going to be sold. So I subtract this and I get y equals 30. All right. So in other words, there were 75 adult tickets and 30 student tickets that were sold. And you know, in a real world perspective, we'd want to do things like that to analyze who's buying tickets so we can kind of market to our target audience. Okay. This one we have 15 coins that are all dimes and quarters. If you have a total of 285, how many of each coin do you have? So again, if I want to say X is the dimes and Y is the quarters, so that means the number of dimes plus the number of quarters should equal the total number of coins, which is 15. And now think about how much money I have. It's 10 cents per dime, so 10 cents is like 0.10, plus 25 cents per quarter, so 0.25 per quarter, equals the total amount of money, which is $2.85. And so you notice the structure to some of these is pretty similar, where we did, oh, this plus this equals the total number. And then the cost of this plus the cost of this equals the total cost. It's the same thing as what we did in the last example. This one, again, I can solve by substitution or elimination. I think most students get a little bit worried about the decimals in here when it comes to doing elimination, so I'll do substitution this time. Okay, so if I take this guy off to the side, I can solve this for either x or y. Either one would be fine. So I'm just going to solve it for x. So I subtract that y from each side. So that's a negative y plus 15. And now I can substitute that in for my x value in the second equation. So 0.10 times x, but instead of x, it's a negative y plus 15. And, don't get worried about the decimals here. We're talking about money. Obviously we're going to have decimals. So I distribute, that's a negative 0.10y plus 1.5. And use a calculator for those kind of things if you need to. Combine like terms, the negative 0.1y plus the negative 0.25y is going to give me a 0.15y. Let me bring that guy up here. Let me rewrite it. And so now I need to solve for y. I'm going to subtract the 1.5 from each side. And now I divide by that 0.15. So I find out the y equals a 9. And now, of course, I got to plug it back in. If I come way back over here, I had x equals negative 9 plus 15. So x equals a 6. All right. So in other words, as I translate this, there are 6 dimes and there are 9 quarters. Okay. This one, Dan's Donuts charges $50 setup fee and $5 per person for catering. Claire's Cakes charges $10 per person with no setup fee. What's the number of people and the price at which the catering service will be the same? And so this one, when we kind of think about this, we need the total number of people and the total cost. Okay, so I'm going to say x is the number of people. And then y will be the price of the cost here, the price of the catering, okay? So in other words, the price for Dan's Donuts, so y equals, well, it says it's $5 per person plus the $50 setup fee. For Claire's Cakes, y equals, the price is going to cost me $10 per person plus nothing, plus no setup fee. So these are my two equations. And really for this one, solving by substitution is the way to go. I already have y equals this. I can substitute it in for y in the second equation. So I get 5x plus 50 equals the 10x. And I'm going to solve. I subtract that 5x from each side. And then I divide. So I get x equals to 10. And then what if I plug that back in over here? I got y equals 10 times 10, which is y equals 100. So in other words, what it's saying is if I have 10 people, regardless of which catering service I choose, it's going to cost me $100. Okay, and when you think about it, the Dan's Donuts costs more if I have less than 10 people because of that $50 setup fee. Then after 10 people, Dan's Donuts will be cheaper. Okay, and this is the kind of thing we use in real life all the time when we're comparing two prices. So if I was having 20 people over, well, then I want to go with Dan's Donuts because it's cheaper. And if I'm only doing a small party of maybe like 8 or 9 people, Claire's Cakes is the better deal. So this one, it says solve by all 3 methods and then explain which one's the best. So if I look at this guy, solving by graphing, the first equation is already set up really nicely. It's in slope-intercept form. And so when I look at this, it's got a y-intercept of 4 and a slope of negative 2. So that's down 2 over 1, down 2 over 1. The second equation is not in a great format, but I can still do the x and y intercept. The x-intercept, if I kind of plug a 0 in for y and divide each side by -2, is 1/2, which isn't great, okay? The y-intercept, if I plug a 0 in for x, I'd have to multiply each side by 2, that's a -2. And so I can kind of see the slope here, it's up 2 over 1/2. So up 2 over 1/2 would be here, up 2 over 1/2 would be here, up 2 over 1/2 would be here. Or you could look at it as up 4 over 1, up 4 over 1. And so this is what I get, and that was kind of a pain. Most of us are probably not going to be able to graph that second equation using the x and the y intercepts. It's going to be a little bit too difficult. You're going to have to solve that for y. And if you take the time to solve this for y, you're going to end up with y equals a 4x minus 2. And then you can go ahead and graph this thing, okay? But there's a lot of work involved as we start to rearrange that equation. I still get the answer, and the answer is 1, 2, okay? If I do elimination, for this one, nothing's lined up. I have to take that first equation, and I have to get it in standard form. So I'm going to add that 2x over to the other side. And now if I write down the other equation, and really this is set up kind of nicely at this point, except for the fact that there's a fraction, but I already had additive inverses. I'm probably going to go ahead and add these up. You're just going to have to deal with a little bit of fractions or decimals. You could think of it this way, 1 plus 1/2, we could just write it as 1.5y. Okay, don't be afraid to use some decimals here. And then over here, I add these up and I get a 3, and now I divide each side. Okay, especially when we have the use of calculators, don't be afraid of things like decimals. So I get y equals 2. I still have to plug it back in. If I plug it back in up here, I get 2 equals negative 2x plus 4. I'd have to subtract that 4 from each side. And then divide by the negative 2. So I get x equals a positive 1, so I still get the ordered pair 1, 2. And I should get the same answer each time for this. It's just a matter of which method ends up being the easiest. And so the last one, substitution, if I look at the original problem, this guy's already solved for y. It already says y equals that, so I can plug that in for y in the second equation. So in other words, I have negative 2x plus 1/2, but instead of y, I'm going to plug in the negative 2x plus 4. And now I just have to solve. I distribute that 1/2, which ends up working out really well because I end up with a negative x plus 2. The fraction kind of automatically goes away. Now I combine like terms. That's a negative 3x plus 2. And now I solve. Subtract that 2. Oops. I got a little too fast for the computer there for a moment. And then divide by the negative 3. So I end up with x equals a 1, which is no surprise. That's what I got every time so far. But now I need to plug it back in. That original equation of y equals negative 2x. I just plug that x value in plus 4. Okay, and now it's just simplifying. It's a negative 2x plus 4, or sorry, negative 2 plus 4, so y equals 2. So I still get the same answer, but now the question is which one of these was the best, which one was the easiest? Really, it's a little bit of opinion, but for the most part, substitution is by far the easiest method here. Okay, I didn't have to do any work up front to rearrange anything. It was already solved for y. I was just able to plug in and solve a simple equation. Elimination, I had to do a little bit more work in terms of rearranging. I had to deal with fractions and decimals. And graphing, I either had to rearrange or I had to deal with some very, very strange values. Okay, so elimination and substitution, elimination and graphing are probably not the best methods here. Substitution is the way to go because one of the variables was already by itself. Okay. And then these last couple, remember inequalities, we just have to decide, we're going to graph these the same way we've always graphed them, all right? But we have to decide whether to use a solid line or a dotted line, and then we shade one side of the equation. So this one has a y-intercept of 2, so that's right here, y-intercept of 2. And then a slope of -3, down 3 over 1, down 3 over 1. So the same that we've always done, but now, because instead of an equal sign here I have a less than, there's no equal to condition, so I just use a dotted line instead of the solid line. Okay? And now inequalities, with inequalities, there's always some element of shading. It says y is less than this guy, so I shade below this line, which is over here. Okay? The other option, if you're not sure about that shortcut and just using the less than symbol, you have to choose a point. Choose the point like 0, 0. If you plug 0, 0 in, you get 0 is less than 2, which is a true statement, so I shade where 0, 0 is. If you get a false statement, you shade the other side of the line. Okay? This one, the y-intercept is a -1, and the slope of 2/3, so up 2 over 3, up 2 over 3, down 2, back 3. There's an equal to condition, so I'm going to use a solid line this time. And then it says I want to be greater than this line, so greater than means above the line, so I shade up here. And again, if you choose a point like 0, 0, if you plug 0, 0 in here, you get 0 is greater than or equal to a -1, which is true, so I shade the side where 0, 0 is. And then these guys, when we're doing it as a system, instead of breaking, so up here we broke the graph into 2 pieces and shaded one side. Down here the graph will be broken into 4 pieces and we'll shade one of those pieces. Okay, so like this first one, the y-intercept is a 3 and it's got a slope of -2. There's no equal to condition, so I use a dotted line here. The next one, I've got a y-intercept of -2 and a slope of 1, so up 1 over 1, up 1 over 1. There is an equal to condition, so I use a solid line this time. And now I just have to figure out which of these sections to shade. You can label them in some way and say, you know, this is like A, B, C, D, or call it 1, 2, 3, 4. And then just think about it. If I look at the dotted line, it says less than, so I would shade below the dotted line, which would be sections D and C that would get shaded if I was only doing that one equation or one inequality. If I look at the next one, if I look at the solid line, it says less than that solid line. Well, less than the solid line means below it, which is sections C and B that would have gotten shaded if I was only graphing that one. So I only want to shade the one they have in common, which is section C. Okay. Again, the other option is to choose a point just like we've done before and do the same kind of process of elimination that we just did. Okay. Check 0, 0 with one of the lines and figure out which 2 sections. Check 0, 0 with the other line and figure out which 2 sections. And then worst case scenario, just pick a point from every section until you find the one that works. Okay. This next one, I've got a 1/2 y minus x equals 3. So that one's in standard form if you do the x and the y-intercept. If you plug a 0 in for y, you get -3 for the x-intercept. If you plug a 0 in for x, you get a 6 for the y-intercept. Okay. And so you might have to take that off the side to do it, but I can graph that using the intercepts. So let's see, -3 for x and +6 for y. And I can even see the slope. It's up 6 over 3, which is up 2 over 1, up 2 over 1, up 2 over 1. There's no equal to condition there, so I use a dotted line. The next one, this is not in any format that I'm used to, so I have to rearrange it. And I do that by subtracting the 1 from each side, so it becomes this. Y is less than or equal to a 2x minus 1. Now I can plot the y-intercept of -1 and a slope of 2. So I ended up with a parallel line here, and that's okay. I have an equal to condition this time, so I use a solid line. And now it's split into 3 pieces. I still have 4 options, but the 4th option is no solution. Okay, and so when I look at this, because the first one's not in slope-intercept form, maybe I'll choose a test point. If I choose the test point 0, 0, when I plug that into the first one, I end up with 0 is greater than 3, which is a false statement. So for the dotted line, it's telling me to shade section A. It's telling me to shade over here. Okay. For the second line, it says less than that line, so less than means below the line. So it's telling me to shade section C, which is over here. And so what happens is, if the one line is shading section A, the other one's trying to shade section C, they don't overlap in any way. We're looking for where do these overlap? What sections do they have in common? Well, these have no sections in common, so I don't do any shading on this one, and I say the answer is no solution. Okay, so this is that special case where it's no solution because there was no overlap. There was nothing that they had in common. If we take a look at these last two, it just says, is the ordered pair a solution to the system in number 17? So really you just have to look and see if it's in the shaded region. So if I look at number 17 and I go to the ordered pair 2, 3, so 2, 3 is up here in section A. So the answer is no, because it's not in the shaded region. Same thing with the next one. It says, is the ordered pair negative 1, 5 a solution to the system to number 17? So if I come up here, negative 1, 5 is up here. It's on one of the dotted lines. So the answer is still no, because it's not in the shaded region. Okay. Hope this was helpful, and good luck on your test.